अस्सलाम वालेकुम मैम।
Walaikum salam.
मैम मीटिंग लाइव है, यू कैन स्टार्ट नाउ।
Yep. Okay. Let's just wait for a few more people to join, maybe
ओके मैम,
2 minutes.
वी कैन वेट फॉर सम मिनट्स
Yeah.
टू जॉइन पर्सन्स।
Okay. Is my screen visible? Okay. Um, so yesterday we were discussing, I think we wrapped up our previous system design session on URL shortener, and then we started discussing the web crawler. Right. अच्छा वेब crawler में we discussed कि what is a web crawler and what is what are its what is its main purpose, like what are its use cases, and then we just established the design scope, like what do we need, what will be the scope of the URL web crawler that we want to design, uh, some requirements, and also the non-functional requirements, and we did back of the envelope estimation. So back of the envelope estimation, we saw that want to uh, we want to, like, our system should be able to download 1 billion web pages every month, and based on this assumption, we like calculated the QPS, queries per second, peak queries per second, and how much storage we will need per month. And for 5 years, we discussed that we probably want to store the data for 5 years. Then in that case, we will need 30 petabytes of storage, right? So we just discussed these things, and then we moved to the high level design. So today we will discuss this high level design for the web crawler. Uh, So for high level, you can see that this high level, this URL, because we discussed that web crawler is not an easy, like it's not a simple system. It's a very complex system, and we are not talking about a small web crawler, but we are talking about something like Google Bot, or like something that is really big, that is like crawling billions of web pages, right? So you can imagine how complex that system could be. So so this system have like multiple components, right? Like we do not want to implement everything in just one repository on just one component, because that will complicate it a lot. It will be difficult to maintain that system. It will be difficult to scale that system and all those kind of things if we implement everything in one place. So what we do usually for big systems is that we develop everything in simple small components, one component, one responsibility. Probably you have heard about single responsibility principle. So we usually use that principle to implement one component that has single responsibility, and it is not doing multiple tasks at the same, like multiple tasks are not being performed in one component. Okay, so based on this, we see that we have multiple components for our web crawler system. For one is the seed URLs, URL frontier, HTML downloader, content parser, and these are some of the URL processing components. Um, we have different storage for content, and we have different storage for URL. Like we are not storing both of these things in one storage, right? So we can also call these microservices. We can implement these as microservices as well. We will probably discuss microservices in some other session as well, but you guys might have already been familiar with microservices. Um, so before we go into like how these components will interact together, you first need to understand what exactly these components are doing, right? So first thing is the seed URLs component. So this is the first component that we have, and this component has the starting URLs for a web crawler. So like we discussed yesterday, that we do not want like all of the URLs or some random URLs to be start with. We just want the URLs that are more meaningful, maybe more popular URLs or based on our use cases. So we just don't want random URLs in our seed URLs. Like we do not want to start with random URLs. So what this seed URLs component do, like it stores the starting URLs for the web crawler. And this is actually the entry point for crawl process. Like we want to start crawling from this website or this website or this URL, etc. Okay. So next, the example of this is, for example, we want to crawl a university website, right? So we will have in the seed, maybe we want to crawl multiple universities websites. So we will have the in the seed, we will have the URL for one university, second university, and like this, like university.edu, blah, blah, blah. And then we will start from this URL, and then further, once we are here in this, once we have downloaded the first web page of this university, then we will extract more URLs from inside that website, which is done by some different components. But right now, seed URLs only has the starting URLs for different websites. It doesn't have all of the URLs from that specific website, just the starting URLs. So challenge is that we want to crawl the entire web. So sorry, the challenge is that since we are crawling in a really really big web, right? We know that World Wide Web has a lot of web pages, like I don't know, trillion or more, even more than that web pages, right? So because of that, we need to define the seed URLs very like हम इनको बहुत cautiously we have to like select the seed URLs at which one we should keep in the seed URLs component. So we want to probably select the high coverage starting points. We do not want some URLs जिनकी coverage इतनी high ना हो. Let's suppose हम कोई ऐसी URL select कर लें कि जिसके through we are only able to crawl few web pages. So we want to go with some URLs in the seed URLs. We want to increase the coverage because we are crawling a lot of web pages, right? Our purpose is to crawl the web pages to gather as many meaningful data as possible, right? So we want to select high coverage starting points. We do not want to select some starting points or some starting URLs that will probably only cover 30% of our required information. We want to select some URLs that should be able to at least cover 90% or above 90% of the coverage, right? So what we can do is we can select the seed URLs in two ways. What we can do is like you can probably get locality based on locality. So for example, we can divide the URL space by geography based on different countries. Like I can say that from USA, I want to select these URLs. From Canada, I want to select these URLs, and so on. So we can do this based on geography, and probably we can also have it more granular. Maybe we can say, well, within USA, I want to select these many URLs or these URLs from this specific state and blah, blah, blah. So we can like select the popular sites, right? Because we want to have as much coverage as possible. So we will select these sites that are popular, right? And second thing we can do is that we can select based on topic. So for example, maybe we want to based on the topic, you can say that based on like I want to gather information from shopping websites, sports, healthcare, education. Then based on this, I will probably select the Amazon or some other shopping websites. These will be based on this category. And for in the education, we can probably select universities or other educational institutions. So we can do this based on this. Like we can do we can select seed URLs based on these two strategies. So this was the seed URLs that will keep the starting URLs for starting the web crawling process. Next component is the URL frontier. So URL frontier जो है, it keeps your components, like it stores your URLs that you need to download, right? So seed URL only has the initial URLs for the websites, right? And sorry, URL frontier has the all of the URLs that needs to be downloaded, right? So URL frontier doesn't have only the seed URLs. It will also have the URLs that we collect during the crawl process from the links that we visit during our crawling process, right? So we probably will be on let's suppose कि हमारे पास एक seed URL है किसी edu website की, right? किसी यूनिवर्सिटी की वेबसाइट की सीड यूआरएल है, लेट्स सपोज स्टैनफोर्ड की वेबसाइट है, राइट? एंड देन वी so this will be the seed URL for that, for Stanford website, right? This will be the seed URL. We start the crawling process from here, and then we select like we for example on the home page we get we get the URL for department's website. Maybe let's suppose like we have the department's website. There is computer science department and the other departments. So we have URLs for those. And then within this, we can have multiple URLs, for example, for faculty, for students or admissions and those kind of things. So what we'll have like in this URL frontier, we will have the URLs, like all of the URLs that we visit during the crawling process. And definitely we will not, like you might be thinking that probably we will put these as manually. No, when we are doing the web crawling process. So whenever we visit a URL that is new, we just add that into the URL frontier component so that it can later be downloaded. So URL frontier has those URLs, and then we can also split the URLs based on this state, crawler state. So let's suppose some of the URLs have already been downloaded, then those can be placed inside this category, and the URLs that have to be downloaded yet, that those will be placed in this category, because it is possible that during a link, because whenever you're crawling a web page, when you are on a different web page, you can probably go back to, from that web page there is a link that goes back to a previous URL, right? So you do not need to reprocess that page or download that page again, because that is already being downloaded. So you split the crawler state based on this. And then you have what this URL frontier does, like it manages the pending crawl URLs, and then it also supplies next URL to the crawler. Like it says that this is the next URL that you need to download and all those kind of things. And we also implement this as a FIFO queue, because the thing is that whenever we are crawling the URL, so the URL that we collected first should be downloaded first, right? So that's why we use FIFO queue, so that we give priority to the URL that came first, like first come first serve basis. So the URL that was visited first will be downloaded first, so that we also collect the information in a structural way. And like it can also track unvisited URLs and visited URLs as well. So there are multiple things that a URL frontier can do, but the thing is that main purpose if this is to store the URLs that we need to download. Next component is the HTML downloader. So HTML downloader simply downloads web pages from the internet, and we already like the URL frontier already kept the URLs that needs to be downloaded. So it collects the URLs from URL frontier and then downloads the web pages from the internet. So yeah, here you will have your URL frontier component, which has URLs stored in a FIFO queue, and then the HTML downloader gets the URL from the FIFO queue in that order and then downloads the web pages. Then we have DNS resolver. So when you are in the so this is your like HTML downloader. Yeah, this is your HTML downloader component, right? So this HTML downloader component definitely needs to communicate with the DNS resolver. We also discussed DNS resolver, like how it is implemented and like how it is designed, like we discussed this and how it does works. We discussed that in first few sessions. So if you guys are interested in learning how DNS resolver solves the addresses, so you can just go through that session as well. Okay, so Isma, what we do is like since HTML URLs that we need to translate first, these need to be converted to the IP addresses, right? So because eventually in the end, every URL is actually mapped to an IP address, So we need to resolve those IP addresses to download the content. So what this HTML downloader components does, it calls the DNS resolver and then gets the corresponding IP address for the URL. So let's suppose you are crawling the wikipedia.org URL, it might have this IP address, right? And you know that IP address usually change most of these do not remain static. So definitely you will this is something that is being handled by DNS resolver, so we do not need to worry about. I will highly recommend that you go through this DNS resolver session as well to get better understanding how this works. This is also a distributed system. Like we discussed that how it works on global scale. And then we have we have HTML downloader, DNS resolver. Then we have the content processing components. So we have downloaded the web pages from the URLs. Now we need to, once we have downloaded the web page, we should be able to parse it and validate it, because it's not easy to, whenever we are reading the content from the data from the web page, we first need to parse it, because we cannot read it read the raw data as without parsing it, and we also need to validate it. So this is what content parser does. And if we do not validate the data content in the content parser, then malformed web pages can cause some problems, and they also waste the storage space. There might be some data that is not meaningful, so we do not need to store that in our storage, which we usually store in the content storage. So content parser will parse the data and it will store it in the content storage, which is different from our other storage, right? So this is also not implemented in a crawl server, because this usually slows your crawl server, because the purpose of crawl server is to crawl the web pages. So if we implement this content parsing in the crawl server, definitely our crawl server will be slowed down. So we do not want to put the load on crawl server. We instead create this as a separate component. And because definitely you know that content parser is time-taking process. You are parsing the data from a lot of web pages. So that's why you keep it as a separate component. So once you have parsed and validated the data, then you have this content scene component. So this content scene component, what it does, like it avoids processing the duplicate web pages, because you know that on internet there are a lot of web pages. There is a lot of duplication, So you want to avoid there is a lot of redundancy. So you want to there is a estimation that around 29% of web content is duplicated. So you do not want to waste your time on processing the duplicate web pages, and this can also cause loops. So you want to avoid those. So you want to prevent storing the same component multiple times. So what you do, how do you identify that the content that you have parsed is already seen? You can do two things for this. One way you can do is since you know that you have these HTML tags, so you compare this with character by character, like you compare the HTML character by character with other HTML, but definitely this character by character comparison is going to be very slow and is not recommended. So the best approach is to use hash value of pages. So you already know that SHA and all those kind of things. So you just keep the hash values of pages and then you compare this, and this is very fast. And also this will this will increase your processing speed, and it will also improve the storage. You do not need to store. You will only need to store the hash values of pages instead of storing the whole HTML contents. So this was what content scene component does. So next component is the content storage component. Like we discussed that for content, we have a different storage. So we keep the content storage separate. So this content storage component will store the HTML page content that we collected, like we used content parser and we used content scene so to avoid collecting the duplicate content, and then we will store that um, in the content storage component. We can use two types of storage for content. We can either use disk storage or we can use memory cache. But definitely disk storage is a better option for very large content. And we also already discussed in the like previous requirements that we have to crawl billions of web pages a month, and there is a lot of storage that we require. So definitely we will go with disk storage instead of memory because this much data cannot be stored in memory. Other option is to like we can use the popular content into the memory cache so that it can be accessed quickly to reduce the latency. Yes, Ifan.
मैं वो पिछली जो स्लाइड थी उसके अंदर आप कह रही थी हैश हैश का मुझे समझ नहीं है कि हैश क्यों निकाल रही है उसकी पिछली स्लाइड्स में। जी यहाँ पर कह रही थी आप हैश के बारे में कुछ कह रही थी आप ताकि प्रोसेसिंग तेज हो जाए।
I think it
ये वाली
was
जो स्लाइड है
this
इससे
one.
पिछली वाली थी वो स्लाइड।
Okay, so the thing is that you have because the thing is here you like आपने एक वेब पेज डाउनलोड किया, राइट? आपने एक वेब पेज डाउनलोड किया किसी मे बी डिफरेंट वेबसाइट से एंड इट हैज द सिमिलर कंटेंट, या फिर सेम ही वेबसाइट से दोबारा एक चीज डाउनलोड की। you probably do not do that, but the problem is कि according to the calculations, there is 29% of web content that is replicated. So something that is replicated, you do not need to process that and store that again and again. Definitely, uh, this is just a repetitive effort, extra effort that you are doing, right? So and you are also wasting storage to store the duplicate content. For that purpose, you need the content scene component that will detect the duplicate web pages, right? So let's suppose you downloaded this web page from here and similar page you downloaded from a different website or from a different place. So these are kind of similar. You need to compare that if the web page that I have downloaded, if the content that I have downloaded is that similar to some other content. इसके एग्जांपल अगर आप देखें कि कुछ लोग होते हैं जो आर्टिकल, लेट्स सपोज आर्टिकल्स लिखते हैं, टेक आर्टिकल्स या कोई भी, एंड दे put that tech article on multiple websites, right? They can place that on Medium or some other sources, right? The same article they can put on some other sources. So from different places, the same content is similar, right? So you do not want to store that same content and process that same content if you have already if that is already present in your storage, right? So for that purpose, you want to make sure that you are not processing duplicate content, and to detect that duplicate content, you can compare the HTMLs of the different web contents. You can like compare those character by character, like because the download the pages that you usually download are HTML contents, right? So you compare those character by character, but that is definitely not a good strategy because that will be very slow, and probably you do not only need to. It is possible that when you are comparing a HTML page to a new HTML page, maybe what you are doing is that this is the new HTML content that you downloaded. You probably need to also compare it with multiple, like you need to compare it with multiple HTML content pages, right? To make sure to see like where it is being like to which if it is duplicated to any of these previous web pages. So that is really slow process. So instead of doing this naive approach, what you do is you compute the hash values of those pages, right? And then you store that in a hash table. So whenever you have a new, so you have the, so So let's suppose here from the same article on Medium had this, like we parsed this content and we stored its hash value in the hash table. From a different website, like let's suppose there are some other articles that are not same from the Medium, right? Which have these different hash values, right? And then you encounter a new web, like you download it from a different web page. You download the same article. For example, you download it from LinkedIn articles, and then what you see is that this you compute its hash value, right? And when you compute its hash value, you will first see if that hash value is already present in your hash table. See, so in this way, when you have found that hash value, you know that the content is already present. We do not need to, like, it is a duplicate content. If you do not do that, if you use the different approach of comparing character by character, then what you will have to do, you will have to compare it with all of these, right? Let's suppose you first compare it with this article, then you compare it with this article, then you compare it with this article, and then you do it also character by character, which is kind of O of n squared, right? Really bad time complexity, and also you're doing this character by character, so the processing time is really slow. So instead of this, you compared the hash value of this article, and then you checked if that hash value is already present in the hash table. If it is present, then you know for sure that this is a duplicate content, and this can be done in a very short, like in constant time, right?
ठीक है, लेकिन उसमें ये इशू हो सकता है कि फॉर एग्जांपल एक वेबसाइट है, ब्लॉग, वो एक जगह पे प्रेजेंट है, वो दूसरी वेबसाइट पे भी उसी वही ब्लॉग पोस्ट प्रेजेंट है, लेकिन इसके जो स्ट्रक्चर है वेबसाइट का, वो दोनों डिफरेंट होंगे, तो उनके हैश जो है वो डिफरेंट होंगे, तो वो हमें से दिखेगा जैसे ये दोनों डिफरेंट आर्टिकल्स हैं, दोनों डिफरेंट कंटेंट्स हैं, दोनों डिफरेंट जो है ना वेबसाइट्स हैं।
अच्छा, उसमें ना ये व्हाट यू डू इज दैट यू डू दी कंटेंट पार्सिंग, जो है ना, कंटेंट पार्सर आपके उसको कंटेंट को पार्स करता है, राइट? So probably what you have done is, like, content parser has parsed the content in such a way, like structure probably different था, but आपकी जो वो थी, once you have parsed the content, then you go to the content scene, because without parsing you do not know how you will be able to compare. So you will first parse the content and then you will compare its hash value. So let's suppose आपने content parsing किया, structure बेशक different था but content was similar, so उनकी hash जब आप compute करेंगे after parsing, that will be similar.
थैंक यू सो मच।
Okay, so okay, so we saw that we will store the popular content in the memory cache and other content in the disk storage. This will help to reduce the latency, because probably it is possible कि आप जो है कोई ऐसी website है which is very popular. An example of that could be let's suppose let's suppose Twitter के ऊपर, let's just take an example of let's suppose कोई voting चल रही है, like या कोई like voting season है, right? So website के ऊपर there is something that user want to like there is a lot some political debate that is going on, that is a hot topic, right? So that is a popular content that has a lot of reads coming through, a lot of requests from the server, like a lot of people are reading through it. So that is the popular content, and you want to, instead of, so इसमें if you will put that in a disk storage, then definitely there are billions of requests that are coming, or maybe hundreds of requests in a second that are coming. So disk storage, you already know, okay, whenever you are reading something from disk storage, that has large latency, right? So it takes more time to read from the disk instead from memory. So in that case, what you do is you put the popular content in the memory cache so that the latency can be reduced for content that is being requested frequently than some other content. So you put such kind of content in the memory cache. And then we have the URL extractor component. URL extractor component. So this URL extractor component, what it will do, this is different from content parser. Content parser was parsing the content of the downloaded web page, but URL extractor is parsing the HTML pages to only extract the embedded links, right? So it is like content parser will actually parse every single of HTML content, paragraphs or headings, titles, all those kind of things. But URL extractor will only be looking at the links tags, right? So it will extract the embedded links from the HTML pages, and then it will convert those relative paths to absolute URLs. Absolute URLs, for example, let's look at this example. So if it was the content parser, then definitely it will parse all of these tags. But URL extractor will only look at these tags. Sorry, not list tags, the href tags, right? So it will only look at the href tags, and then from here it got these 4 URLs, right, from Wikipedia. This is, for example, a Wikipedia page. So it has these 4 URLs. But this URL, like you see that these links within the embedded links within the web page are not absolute URLs. It only has the paths to the specific web page. So what it also does, like, first of all, it extracts these links from the href tags, and then it will append the actual path, like previous path to this path to your URLs, to make these, convert these relative paths to absolute URL, so that it is when you are downloading the content, it does not say that URL doesn't exist. You are actually pointing to the actual IP, because you have to get the IP address for that URL. So if you only provide this thing, it is something that does not exist on the web. You need to provide full address of the URL. So this is what your URL extractor does, and then we have the other components. So once you have extracted these URLs, right? So now you have to you cannot say that I have these URLs and then I will add these in URL Frontier for downloading. Before downloading, you have to filter the URLs, because there are some URLs that might be malicious. There are some URLs that are in the blacklisted list. In the blacklist, you do not want such URLs. You just want to filter such URLs. There might be some URLs that are broken. You would like to filter those URLs before adding these to your URL Frontier. So this is done by the URL filter component. So it will exclude irrelevant or unwanted URLs. And then it will also remove URLs that are in blacklisted or restricted sites. So this is what your URL filter does. And after this, before adding that into the URL Frontier, there is a URL scene component. This URL scene will be tracking the visited URLs and the URLs that are already in the Frontier. So if there is a URL that is already being visited previously, it will not put that back into your URL Frontier. So this is what URL scene does. It will first check if the URL is already in the URL Frontier. If it is not, then it will add that. Otherwise, it will discard it. So this will prevent the duplicate web crawling and infinite loops, because you do not want to, how an infinite loop can happen. So let's suppose here you had this seed URL of a let's again discuss the Stanford University website. So you are crawling, this is the seed URL of your Stanford website. So here you crawled, let's suppose, different departments, and within the departments you probably went to faculty. In the faculty, you have the pages of your each faculty member. So let's suppose within this URL, it is all again linked back to the department. Like this, for example, this faculty member is a professor in this department. So there is the link back to this this URL. So if you will not remove the duplicate URLs, then what will happen? We will go in a loop, right? In an infinite loop. We will again process this URL, then we'll again come here, then we'll again go to this page, and from this page, we will again go back to this this URL. So we want to prevent duplicate crawling and also infinite loops. So and if we do not prevent this, that what will happen, that whole crawling process will be duplicated. Not only just we will again download this web page, we will download this web page again, then we will this will go to the content parser will again parse the content and all those kind of things. So you have to prevent that. This is implemented like URL scene component looks for visited URLs. This is implemented using Bloom filters and hash tables. We'll also discuss Bloom filters in some other in some other maybe session. But for right now, like we can see that we can implement this with hash tables or Bloom filters. Next thing is the URL storage. So this URL storage will simply store the already visited URLs, right? And yeah, so this was all about our components for the web crawler. And now we can look at like how this will, since now we know that what each component does, what are the responsibility of each component. Now we can look at how a crawler workflow will look like. So first thing is like here we start from the seed URLs. So we have the entry point URLs in our seed URLs component, and then URL frontier will have so this seed URL is stored in the URL frontier. These seed URLs are stored in the URL frontier, and from it, then HTML downloader, it can do this parallelly or one by one. Definitely for a distributed system, we want to download the URLs, like we want to download the content in a parallel or distributed fashion, right? So what it does is from the FIFO queue, there can be in URL frontier, there can be multiple FIFO queues. Like it's not necessary that we'll only have one FIFO queue, so it can have multiple FIFO queues. So HTML downloader will be getting the URLs from the URL frontier, and then it will download the HTML content. But before downloading the HTML content, it will first need to communicate with the DNS resolver to get the IP address for the URL that it is trying to download. Once it gets the IP address, then it will download the content, and then it will pass that downloaded content or downloaded web page to the content parser. Content parser will parse the HTML content, and then it will pass to the content scene. Content scene will compute the hash value of the download of the parsed content, and then it will check if it is already present in the content storage. If it is already there, then it will discard that content. If it is not there, then it will store that in the content storage. And then we will have the link so this page is being done, then we will go to the link extractor. In the link extractor, this link extractor will this link extractor will look at the href tags from the from this content, and then it will extract all of the links from the web page. And then it will, once it has extracted those links, these will go to the URL filter. URL filter will filter the unwanted URLs from the extracted links. And then it will go to the URL scene. URL scene will see if the link is already present in the URL storage or it is already being visited. If it is there already visited, it will just discard this. Otherwise, it will store it in the URL storage, and then it will store it in the URL frontier. URL frontier will actually be communicating with the URL storage, right? So it will store it in the URL frontier, and now URL frontier can start crawling the next web page so in this way you just continue crawling in this hierarchy. So you crawl this first URL, then you have different URLs, then you will continue crawling like this. So you crawl the whole web page, whole website like this way. So this is how your web crawler workflow will work. Any question till here?
मैम ये डीएनएस रिजॉल्वर इसका क्या काम मतलब है?
अच्छा, DNS रिजॉल्वर जो है ना,
और ये फिल्टर का बता दें बस.
Okay, so DNS resolver, what it does is on the internet, you have these what the URLs are are something that is readable, right? because in actual how your web pages are, the web pages are actually stored on some servers, right, which have some IP addresses, right? So these are just aliases. URLs are only some aliases that are actually pointing to the actual IP address. So there is a so it's a actually होता क्या है कि आपकी URLs जो है ना, these are mapped to an IP address, because that is a physical address or of a server where your website is hosted, right? So so for that purpose, you cannot directly so for this purpose you have to communicate with the DNS resolver. DNS resolver करता क्या है कि आपकी जो ये URL है ना, इसको इसके अगेंस्ट जो IP एड्रेस है ना, जो मैप्ड IP एड्रेस है, ये वो आपको रिटर्न कर देता है. From here, it looks like it's a very simple process, like maybe it's just a hash map that has URL and there is an IP address that is attached to it. But no, your DNS resolver is not a simple, it's a very, very complicated component. And since it is working at global scale, you have the servers on different geography, like different locations in different countries and all those kind of things. So DNS resolver is a very complicated distributed component there, and how it so, but for now, just consider that it just returns the IP address against a URL. And then once you get the IP address, then you will communicate what your HTML downloader component will do. So it will go, it gets the IP address of the URL, then it will do the handshake with the server, because now it knows the location of that server, right? Now it knows the location of that server. Your HTML downloader knows the location of that server, so it knows that it has to communicate with this server, so it does the handshake. I think you can there is TCP or UDP kind of handshake, but I think you do not need to go into those details. The thing is that you need to know that like you need to know the physical address of the server so that you can communicate with that server and then download the content from there, right? So for if you want to, I will highly recommend that you go with the like how DNS resolver works, and also recommend to like we had the first or second session where we discussed like what happens when a client or when a user hits enters a URL on a website, like what happens behind the scenes. That is a very good thing. You will actually understand how actually this process works. So I will recommend that you go through my second. You can just look at if it was second or third session. So that is quite very detailed, like how this thing works. So you can go through with that session. And second, you asked about URL filter, right?
Yes.
So URL filter, what it does, like you have extracted different links from a web page, right? So let's suppose Stanford की website पर थे, and you extracted the links of different departments, computer science department, mathematics department, and biology department, and so on. So you extracted the links for those web pages. Like in fact, this is let's suppose let's suppose there is a department that has a very confidential information, right? Or maybe there is a web page that has very confidential information that you do not want to, maybe the current research that is going on, and you maybe there is a page where the current research that is being going on, and that is only something that is restricted and you do not want to share, right? So what happens is URL filter will actually filter out the 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 URLs that are restricted, right, that we are not allowed to crawl. So it will just look at those URLs and it will discard those, and it will not add those to your URL frontier. Or it can also have some URLs that have malicious links, right? Or web pages that have malicious links, so it will discard those as well. And then it can also have some URLs that are blacklisted, right? So it can also filter those. So this is what URL filter does. It just filters the unwanted or restricted URLs from your extracted URLs so that you do not put them in the URL frontier for downloading. I hope you got the answers. Okay. Okay, so Okay, so we discussed how the overall high-level design will work for our web crawler, but we discussed different components, how these work. So next we can do is the design deep dive, right? So this is what you usually also do in your system design interviews. You first discuss the high-level design, and then you go into the low-level design to discuss like how a specific component will be working. So let's just go into the design deep dive. Yeah. So you can the crawling process, you can do it in either the depth first search or breadth first search. I think you guys are already familiar with DFS and BFS. So depth first search is what it does is like because you know that you have the web pages in a hierarchical manner, like this. So this is the main web page, and that it has links to different web pages. Like we can navigate to different web pages, and from this page we can further navigate to more web pages. From this we can further navigate like this. So this looks like a tree structure, right? Or probably a page is also linked back to another to a different to previous web page. So but in fact this is not like a tree structure, it's more like a graph, right? Because trees cannot have the cycles, and like trees usually have only one direction, but graphs have two directions, right? They're bi-directional. You can go back to the previous link. So it's like your web page hierarchy looks like a graph, right? So and when you have to crawl the web page, then you can do that whenever you know that whenever you are exploring the graphs, you can do that with either DFS or BFS. So same thing we can do here with for we can do the same thing for crawling the website using either DFS or BFS. So like if you are doing the DFS, what it does is, so if you have like so what you do in the DFS, you first start from this and then you go in the depth like this. You continue go in the depth. So that is DFS. If you are doing breadth first search, that is depth first search. And if you're doing breadth first search, then you do that level by level. You first start from here, and then you on the first level you explore these, then on the second level you explore these, on third level you explore these, and so on. So this is breadth first search. Now, um, how the graph for a web looks like on the nodes you have the web pages, and on the edges you have hyperlinks that this is the web page, and then this is the hyperlink. So on the edge, this is the node, and this is the edge. So on edge you have URL link, and then on the node you have the web page. So we also discussed like how the DFS will work. It can reach very large depth. So it is possible that if you have used the depth first search, then you are continue going in depth, and the depth can be really, really big. And you also know that if you are doing DFS, then the call stacks are stored in a stack. So your stack can be, if the website is really big, then you are just continuously increasing your stack space. So it's not suitable for large scale web crawling. Instead, what we do is, instead of using DFS, we use the breadth first search, which is the commonly used approach. And you also probably know that BFS is implemented using using FIFO queues. So in this case, URL will be processed in like if we are here, first URL is processed here, and then in the queue we'll put these. So these were put first in the queue. So if we have these URLs also in the queue, then these will be processed first. We cannot process these URLs because these were visited later. So we'll use DFS for crawling, sorry, BFS, breadth first search, for crawling the web process. So what are the challenges with standard BFS? It's not like the BFS is also like we will not have any challenges with breadth first search. We definitely have challenges with this as well. What happens first? Very very critical issue with this is like we discussed that we need politeness. Like this we discussed in our requirements section, that our web crawler should be polite. Like it shouldn't be sending too many requests or overload the server where we are getting the like if we are crawling the Stanford website, then it shouldn't put a lot of requests on the Stanford servers because it will overload that server. So it should be polite, right? So, but what happens with standard BFS, like look at this example. So we have wikipedia.com and this is the seed URL, and then we are crawling this website. So when you are crawling this website, you will see that all of the other pages are most of the time, like 90% of the time on the web page, these are like pointing back to the actual host, wikipedia.com host. So since you are like all of the pages you are trying to crawl are pointing back to the same host, then what you are doing is that you have a lot of URLs that are pointing to the same host in the FIFO queue, and then you are sending the request to the same host. You are sending a lot of multiple requests to the same host, which will overload your server. So that is not polite. So and it doesn't have any prioritization, so this will also treat all pages equally. So what we can do to improve this, we can prioritize the crawling based on the page rank or importance, or we can based on the web traffic, like if on the if on this host there is already there are already a lot of traffic or a lot of requests that are coming, then we will probably not send another new request to this web page. We will instead probably wait for some time until the load is lower, and then we will send new requests, and maybe we can use some threshold that if there are these many requests already coming on the server, then we shouldn't send new requests. We should wait until the load is lesser, and then we can send new requests back to the host. So and we can also update the frequency, like how frequently we need to send requests to the web host. So okay, we will, I think, discuss the URL frontier deep dive in tomorrow's session because we are already out of time. If you guys have any question, then please ask, and then we can end the session. Okay, so I think there are no more questions, then we can